Embedded C, understanding the compiler, linker, debugger. Imagine building a robot or a smart device. You write the code in a language called embedded C, but how does it turn into something your microcontroller can understand and run? That's where the compiler, linker, and debugger come into play. They work together to make your code come alive on tiny microcontrollers used in electronics and embedded systems. First, the compiler is like a translator. It takes your high-level C code and converts it into low-level machine instructions that the microcontroller can understand. This process involves checking your code for errors, optimizing it to run faster or use less memory, and then creating an object file. Think of it as translating a story into a language the microcontroller speaks. Next comes the linker. If your program has multiple parts or uses libraries, the linker combines all these pieces into one complete program. It resolves references between different code modules, making sure each function or variable points to the right place in memory. It also assigns specific memory addresses to your code and data, fitting everything into the limited space of your microcontroller. The final output is a binary file that can be loaded directly into the microcontroller's memory. Finally, the debugger is like a detective tool. It helps you test and fix your program by running it step by step on the actual hardware or an emulator. You can pause the program at any point, check the values of registers and memory, and see how the program interacts with hardware like sensors or motors. Debuggers connect to the microcontroller through special protocols like Joint Test Action Group or Serial Wire Debug, giving you control over the execution process. This makes troubleshooting much easier and helps ensure your embedded system works reliably. In real projects, you write C code to control hardware components. The compiler turns this code into object files, which the linker then combines into a single binary image. This image is uploaded to the microcontroller's memory. During development, you use the debugger to step through your code, watch how variables change, and verify that everything functions correctly. This cycle of compiling, linking, and debugging is essential for creating efficient and dependable embedded systems in fields like automation, automotive control, and Internet of Things devices. All these tools are like the core team behind the scenes, making sure your high-level ideas turn into real, working electronics. Without them, turning your embedded C code into a functioning device would be nearly impossible. They help you write better code, find bugs faster, and ultimately build smarter, more reliable embedded systems used every day in electrical engineering applications.